Hello and welcome to another one of D's ADD videos. Today we're going to look at another example of an exact equation. Slightly more intermediate example here. So again, we got to look at this m, derive it with respect to x. We know it's m because it's connected to y, dy there. Derive this n with respect to y. We know it's n because it's connected to x, and you always do the opposite partial derivative. So this is what I was saying. M is y sine squared x dm dx, oops, sorry about that, is equal to y comes along for the ride, the derivative of sine squared, you bring down the 2 and derive or rewrite the sign, the chain rule, right? If you remember, that's the same thing as sine. So you derive the outside, you bring down the 2, rewrite the sign, and then derive the inside. Derivative of sine is cosine. So now we got to derive this one with respect to y, n, which is a little bit easier in this case. And we're going to have a oops. If I derive that with respect to y, I'm going to get the same thing, 2y sine x cosine x. So they do equal, they are exact, so let's get to work. Now, don't just blindly approach these. There will be certain ones that are easier. For instance, it's not much of a difference in this case, but integrating this with respect to y is much easier than integrating this with respect to x, because you just got to integrate that single y right there. And here you got to do a little u sub. So depending on how good you are with your integration, you might save yourself a lot of trouble by picking the easier of the two integrals. You do have the choice. So I'm going to go with the sine squared. And then at this point, what you do is you integrate that with respect to y. And then since we integrated with respect to y, we put a g of x there. That equals the constant. And then we derive it with respect to the variable you now introduced over there. So when I do that with respect to x, I'm going to get y squared sine squared x. Oops, I'm sorry. No, I'm not. That's going to become the 2 sine x cosine x plus g prime equals 0. And then we set this equal to the other expression, the y sine squared x. Is that the one? Or is it the, no, it's going to be n. And actually this 2 cancels with the 2 that was on the bottom. So when I do that, I notice that again I have no g prime of x. I'm making these problems up, so I apologize. I'll try to get one in which there's a g prime of x or y here once we do it. But that does make your life easier here. And your general solution is just going to be that. Okay, let's see. Can I make up some initial conditions here? Let's try y of pi halves actually no, let's do pi over 6 equals 1. Let's try that. So we can go from a general solution here to a particular by solving these initial conditions. This is going to be your x value, this is going to be your y value. So here when I plug in, I get 1 squared over 2 sine squared pi over 6 equals c. So at this point, the sine of 30 degrees is going to be 1/2 squared times 1 over 2. So it's going to be 1 over 2 cubed, which is 1/8. So the particular solution now can be written down as y squared over 2 sine squared x equals 1/8. And you can clean it up a little bit by multiplying by 2 on both sides to give you y squared sine x equals 1/4. Alright, so this is an example with initial conditions, and the next one will have the desired g of x or g of y not equal to 0. So practice, practice, practice is the most important part. Thank you and have a nice day.